says if you are given x 50, 32, y, and 8, okay, they form a quadratic pattern. You need to determine the values of x and y, right? So we have got x, we have 50, 32, y, and 8. So the first thing, determine your first differences. That will be 50 minus x. That will be minus 18. And that will be y minus 32. And then you have 8 minus 1. Then you also need to determine the second differences. Here 2. So that will be minus 18 minus 50 minus x. And then you have y minus 32 minus 18. And then the last one, this will be 8 minus y minus, this is a binomial, so you must put it in brackets, y minus 32. Okay, so you're supposed to do this. Some of the key concepts that you need to remember are that the first differences, they form a linear pattern. Okay, the first differences of quadratic pattern form a linear pattern, which is a grade 10 pattern. So this is a linear pattern. Okay, and that linear pattern has got a general term based on how I taught it, Tn equal to, we can use An there, An plus C. Okay, whichever way you write the general term, you can use Bn plus Q and so on. But that general pattern, it's linear. Okay, so if you want to determine x, in this case is the first term, there are many ways of carrying on. Okay, but my suggestion would be, if you are given a question like this, to determine this x here, you have to use this, the fact that the second differences are equal. Okay, you may need to use your knowledge of simultaneous equations. I can't teach you simultaneous equations, that's grade 10 and 11. As part of application, you should see now, by this time in grade 11, you should know that concepts like simultaneous equations, quadratic equations are now part of application to you. So when you see a question like this here, you need to remember that the grade 10 simultaneous equations and quadratic equations earlier in the year, you may need to apply that thing. Okay, I don't have to tell you that, you must see. Alright, so here, this expression here is equivalent to that. Okay? It's also equivalent to this. Because the second differences of a quadratic pattern are equal. So you can equate this to that. You can equate this to that. You can also equate the first expression to the third expression. They are all equal. Okay? So, if I want to find x here, because I've got two unknowns. In maths, if you have got two unknowns, means you need two equations. If you've got three unknowns, you need three equations. Okay? If you've got four, you need four equations. But for you guys, only generally it's up to two. Okay, three becomes more complex. Alright? So I need to equate this to that. Alright? So on the next page, I'll say minus 18 minus 50 minus x. Okay, let's check. Minus 18 minus 50 minus x. What's wrong with this? Alright. This will be equal to y minus 32 minus 18. Y minus 32 minus 18. Okay? Let's simplify this. If you simplify, you get minus 68 plus x, and that will give you y plus, okay, actually it will be a minus 14. Okay? Then we can simplify this further and write it as x equal to y minus 14 plus 68. But that will give me plus 54. So this can be your equation 1. Okay? So that's what we have there. Then we are lost to go through a simultaneous equation. Listen, the first day that I introduced the quadratic pattern, I told you that the second differences are what? Are equal. The second differences are equal. Here, it's only that the second differences, they are in terms of x and what? And y. Are you following that? The second difference are in terms of x and y. You have done algebra, grade 9, grade 10, and grade 11, term 1. Let me warn you now. You will never be taught the basics of algebra again. It's now application time. It's application time. You can't see a simultaneous, a pair of simultaneous equations, then you say, what is this, what is this? No. That time is gone now. All right? So I equated this expression to that. Okay? Because I want to solve for x and y. There is no other way to solve for x and y here directly without algebra and knowledge of linear equations. In linear equations, grade 9, grade 10. Yes?
Instead of being simultaneous equation with x and y, you just equate the second one to this one because you only have the variable in y.
That's what I'm going to do. That's why I told you earlier that you need to create two what? Two equations. I use the first and the second to create the first equation. The second equation, I use the second and the what? And the third.
So you do the simultaneous equation. I just equated those two.
No, but how did you get x?
I got the y value.
Tando, there is no way that you can solve for two variables without creating two equations.
That's what I'm saying.
Yeah.
You can use the second difference and the third one because there's only y in both of them. There's no x there. So you're only solving for y.
That's the first equation.
Yes, sir.
Then how do you solve for x?
Then you got the y there.
If you solve for x, you need another what?
You need another equation.
Yeah, that's what I say.
No, you see, there's only one way to do it.
No, I never said, listen, there is no way that, you see the way you are saying it, you are only saying it that you solve for y first, you solve for what? X next.
Yes.
But you used what?
But I'm talking about the simultaneous.
Well, what's wrong with that?
No, I'm saying, because you said you can only do simultaneous, there's no other way.
Okay, by simultaneous, you understand what I mean? It means you need two what? Equations.
In one question.
Yes, in one question. Okay, let's tell you. So this one here, Sandro, you can do it the way you feel like. Y minus 32, right? Minus 18, minus 18. This is equal to. Are you following this?
Yes.
Right? Then I equate that to this one. So y minus 8, y minus 8, minus y minus 32. Okay? Let's simplify this now. Well, we're going to simplify this. There are many ways of doing it, but I'm just going to do it this way. Y minus, this becomes a plus, so we get minus 14 there. And then on the other side, we will get 8 plus 32, you get 40 minus 2y. Right? So what this means is, I can take the minus 2y. Please, I'm not supposed to be teaching the basics of equations. Well, that's not grade 11. Take the minus 2y to the left, you get 3y. Take the minus 14 to the right, you end up getting what? 54. This, I can call it my equation what? I can call that one my equation 2. Alright? Then, since it's only a linear equation in one variable, What that means is that y is going to be 54 over 3, which gives you what? 18. Right? So I found what? Y. Then I need to find x. So I go back to my first equation. Are you following?
Oh, yes.
So x will be equal to 18 plus 54. And that will give me 72. Okay.
How many marks is this stuff? 3 marks.
Maybe 4, 5, because it involves application.
3 marks.
Right, is there anybody who has got a question then? So your knowledge of linear equations is extremely important to do this question. Yes?
I don't think that's a good thing.
Yeah, it's okay. It's okay.
But second, the second we do that, you see it's not correct.
No, listen. As long as it's the correct mathematical concepts.
You said right is correct. So we got more of repeat and all three are simplified. You know that? So,
As long as you use the correct mathematical concepts, it's fine. It's fine. It's fine because it is based on your understanding. It is okay. Alright. Okay. Is there anybody else got any question?
we also determine the equation. That's it.
Well, okay. Yes, but for this question now, you were not asked to determine the general term. So you just stop at finding what? X and Y. Is there anyone else who has got any other question? The quadratic pattern is very, very important up to metric. Okay? So make sure you know. Let's do number C now. So C1, okay, the first thing is you're given that pattern. So you have minus 4, minus 1, minus 2, minus 7. First thing, the question says determine the general term. But before I even start answering the first part, I need to determine my first differences. So minus 1 minus 4, that will give me a 3. Minus 2 minus 1, I'll get minus 1. Minus 7 minus that, I'll get minus 5. Right? Hope everybody is following me. Right, then D2, minus 1 minus 3, minus 5 minus 1.
Minus 7 minus 2 is equal to.
It's minus 7 minus 2. You are subtracting minus 2 from minus 7. Okay, like this. Minus 7 minus 2. This will give you minus 7 plus 2. And you get minus 5. Right? Okay, are you following that? Okay. Any questions so far? So the first thing that this is what you must do. And always make sure your second differences they are what? The same. If you make a mistake and you find two different values, like in this case, it means you made a mistake somewhere. So you have to go back and redo your differences. Okay? Now that I found my first difference, second differences, I can answer number 1, determine the general term of the sequence of the first differences. So we want a general term for these numbers. They form a linear pattern, right? The good thing is that the common difference of these terms here, it's a what? Minus 4. So if you go to the general term which I taught you, right? So number 1, it's Tn equal to, I prefer to use An plus C. So A is gonna be minus 4. Please don't confuse the A for the general term of a linear pattern, and the A for the general term of a quadratic pattern. Okay, don't confuse the two. So let me choose a term here. I'm going to use -5, which is T3 for the linear pattern. Okay, so where there is Tn there, I'm going to put -5. Where there is A, I'll put -4. Where there is N, I'll put 3 so that I can calculate the constant. Are you following that?
Yes, where did you get the reason for?
What's the common difference?
Oh, okay.
Then I chose T3 of the first differences, which is -5.
Yes, yes.
The position of this of -5 is a what? 3. So N is 3. N is 3. The common difference A is -4. Tn is the value of sorry, the value of a term in the pattern. I chose -5. Then you simplify it here.
So let's say, sir, you use -1, you use 2 instead of 3.
You use what?
-1.
Yes, if you use -1, then you put n equal to 2.
And you still say -4.
Yes. The common difference doesn't change. Are you following that?
Yes.
Huh?
Yes.
Okay, so we have got C. So our general term will be Tn equal to -4n, right? Plus 7. So this is the general term. If you did the work, then you should have got this answer. Okay? It's not difficult.
Wait, so was this a linear?
The first difference is they form a linear pattern. First differences of a quadratic pattern form a linear pattern. Did you do the first part of the question? What answer you got?
I treated it as a quadratic.
That's incorrect because the question clearly says determine the general term of the first differences. Is the general term of the first differences. The first differences of a quadratic pattern form a linear pattern. We're following that. First differences of a quadratic pattern form a linear pattern. Right? Then the next question, calculate the difference between the 25th and the 26th terms of the quadratic pattern. Calculate the difference between the 25th and the 26th terms of the quadratic pattern. Right. Now, I gave you the homework on purpose because I also wanted you to think. Okay? I also wanted you to think. Even when you write your test on the 14th, there are some questions where you have to what? Think. I don't want to take your ability of thinking because it's part of math. Right? Who can tell us what this means? What the question wants? Because if you don't understand what the question is saying, it's very difficult for you to answer the question. Yes, sir.
So I think you must first get the general terms of the quadratic, and then you start with 25 plus 26 and two different equations on the ends. Yeah? So an you sub 25 squared plus b 25 plus square root of 6. And then you minus the value that you get in 25 and 26.
Okay. Thank you very much. That's one way that you talk this. I think probably it should be the easiest way. Okay? But the other thing as well that I want you to be aware of is that besides doing it the way that you just told us, there is a shorter way of using the linear pattern stuff. Okay? Without getting the quadratic. But I think I've got time. Let me try to probably do both ways. Okay? Both ways.
Start with the quadratic.
Let's start with the quadratic. Right, number 2. So we are doing number 2. Now, if we start with number 2, it means we have to find the values of A, B, and so on, and what? And C. Alright? So let me. So this is number 2 now. So we know that 2A is going to be equal to minus 4. Because our second difference is minus 4. So A is going to be what? Negative 2. Right? You following that? Then 3A plus B is going to be equal to this. That's 3. Okay? So we end up getting B being equal to 3 minus 3 times minus 4. And this will give you plus 12. So we'll get B equal to what? To 15. If you did the question, you must check that. Right? If you take the 3A to the other side, because A is supposed to be negative 2. Right, so this give me positive 6 plus that, I'll get B equal to 9. Yes. Minus 2 times minus 3 gives you a positive 6. Positive 6 plus 3 gives you what? Right, then T1 equal to A plus B plus C. The first term of our quadratic pattern is this. The following then, negative 4. So, negative 4 is equal to A, which is minus 2B is positive 9. We want to get C, so it gets minus 4 plus, so equal to 7, 7 plus C. So C is going to be minus 11. Are you following here? Right? So the general term will be Tn equal to minus 2n squared plus 9n minus 11. Yes.
Sorry, how did you get B?
B, we used the formula which I explained to you on the first day. That expression 3A plus B is equal to the first term of the first differences. Your first term of your first difference is that. If you use 5A plus B, okay, it means that 5A plus B will be equivalent to this. If you use 7A plus B, that 7A plus B will be equivalent to that. But generally, as I taught you on the first day last week, normally we use 3A plus B to be equivalent to the first term of the first differences.
So 1 plus 2 equals 0.
What?
If it goes 3, 5, 7, and 4, 3, 3, 1.
You can't talk about a term which doesn't exist.
But 0,
You can't talk about a term which doesn't exist. Let's not talk about a term which doesn't exist. Okay? Yes?
So, sir, if you use 1, you would take 5, 8, 9.
Yes.
Oh, okay.
If you use minus 5, then you use what? 7A plus B. It is your choice. However, generally, we normally use the first term of the first differences. But if you like to use the second term, the third term, it's your choice. I'm not going to prescribe to you and say, please use 3A plus B always. No. If you can memorize 5A plus B, fine. 7A plus B, fine. 9A plus B, that's fine with me. The most important thing is getting the correct value for B. Is that clear?
Yes.
Right? So we are there now. Then, since we now know the general term, the question says calculate the difference between the 25th and the 26th term of the quadratic pattern. Therefore, we can subtract T25 from T26. So we'll say here, we'll say T26 minus T25 of that quadratic pattern is going to be equal to minus 2 times 26 squared plus 9 times 26 minus 11. Then you subtract that answer from, so you subtract T25, which will give you minus 2 times 25 squared plus 9 times 25 minus 11. Can you do the math there? What will be T26 minus T25 equal to? You're supposed to have your calculators in front of you and doing the right. But I want you to pay attention carefully as I show you the second method. So this is method one. Be aware that we are using method one here. In a memo, this method here will be provided, but it's not the only way. Okay? So you can use the general term of the quadratic pattern. Another way is to use the general term of the linear pattern. But this is how you can do it. Please make sure you pay attention carefully. But I'm going to ask you a question just to check your understanding. If I give you a quadratic pattern with 25 terms, how many terms are going to be in the linear?
24.
To be 24. The number of terms in a linear pattern is always going to be one less than in the original quadratic pattern. All right? Are you following that? So, this is so interesting. Right? This is very interesting. So, for our question, it means that our quadratic pattern is 26 what? 26 what? Terms. So how many terms are in the linear? It will be 25. Are you following this side here? You follow? Right, let's look at what's here. How many terms do we have in the quadratic pattern for this example here? So far, I'm talking about what you are seeing. We have got 4. And how many are in the linear? 3. Okay, so always the number of terms in the quadratic pattern is 1 more than in the linear. Okay, always. So if I want to find the difference between two terms in a quadratic pattern, I may just use the general term of the linear, because this difference here is part of the linear what? Linear pattern. Since the maximum number of terms is 26, all I have to do is find T25 of the linear pattern. The good thing is, I've got the general term already for that linear. This is the what? The general term. This is the general term. Right? So I'm going to use that. Okay? Then, if we get two different answers, then something is wrong somewhere, either here. Are you sure that this is correct? Can you verify for the last time? Listen, verify. Let's verify this first before we can. Because I already noticed like a discrepancy. Discrepancy between what? Between this answer and the one that I'm supposed to get with method 2.
So maybe you don't answer.
Maybe it's interesting. All of you are supposed to be putting that value. Don't be a spectator. Like someone who is in a football stadium and then they are watching others play.
So,
that's not
can you fix my calculator?
That is the
Can you just wait for that?
Are you telling that this is the correct answer for 26?
So, can you just help me fix my calculator?
So it's answer that negative. Oh yeah. So say you're gonna get the answer. So we both confirm but negative.
That's correct.
So, I don't understand both.
So listen here. What that means, I suspect, can I have your attention? That this minus 1036 is supposed to be the one for T25.
Okay.
And this minus 1129 is supposed to be the one for T26.
My bad. I'm sorry.
So that's the answer.
Yeah.
So let's correct. I'll tell you how I figured that out.
Okay, so too smart.
So let's remove this.
So this is the answer for 226.
Alright. So minus, supposed to be minus 1 1 what?
1129.
1129 minus 1036. And that will give you negative 9. Okay. Now it's correct. Alright? So let's carry on. So I say for method 2, we are going to use the general pattern. It's here. The general term of the linear is this. Right? I saw, okay, just to give you a clue how I saw that we might have the same method 1. If you put n equal to 25 here, you get minus 100. Okay. Minus 100 plus 7 should give you minus what? 93. Are you following?
You're very sharp.
So this will be minus 4n plus 7. So here, all we want is we want t25. So that will be minus 4 times 25 plus 7. And that will give you minus 100 plus 7, and you get minus 93. And this will be a shorter way as compared to the other one. But it's not important whether it's a short way or it's a long way. What's important is you being able to use either of the two methods.
So just to verify what this method is about, you get the circuit difference from the quadratic, and then you take the smaller number of what you must minus, and then you sum this.
Yeah. Okay. Obviously, in our case, it will be T26 minus T25.
Let's say I 10 minus 9, so I just take the 9.
Okay, I don't want to say that. You get your general term first of the quadratic, substitute the positions correctly. Substitute the positions what? Correctly. Because the objective is to get T25 of the linear. That's the objective for the question. Okay?
So you take the smaller number.
Then when you are doing a subtraction, it is possible that some questions, because it's a quadratic pattern, T25 can be greater than T26. Like in this case. Alright, I hope you are aware, all of you, I hope you are aware that minus 1036 is greater than minus 1129. Are you aware of that? So this one is greater, this one is less. Okay? Sometimes you have a bigger value here, and here you have a smaller value. But what's important is get your calculation of your difference correctly. That's what's important.
Yes. So what I don't understand is, I understand where you found the A, B, and C. And then so I don't know why you subtracted it into a quadratic equation to find 26.
Yes.
26. But then to find T25 you subtracted it into the linear equation. And then
Yeah, why specifically 25?
Okay,
Not
look
26.
no, I'm asking you.
Before I started doing this question, I told you that there are two methods of getting the answer. The first one, which is the one that you proposed, that you use the quadratic what? Pattern. Get the general term of the quadratic pattern. Right? Find T26, find T25. Get a difference of the two. We got it as what? Minus 93. Do you understand that part?
No, so because you just put 26 there is the subtraction. Or you
Okay, look here. Yeah. If you have been asked to determine T26 of the quadratic pattern, how are you going to get it? That's what I did here. If you're asked to determine T25 of the quadratic pattern, how are you going to get it? Substitute. Then how do you find the difference between the two? That's what I did here.
It's one whole like
part of the that goes through the house.
That makes sense now.
Okay, all this, because I didn't have space, just to clarify as well, is one expression. Yeah, because I didn't have space. Okay.
Exactly. You don't have space. So I have to use a small term for the bigger term. Or can you use any term? 26 is the term.
Right.
25
It depends on which method you want to use. Do you want to use,
It's not by the second method.
yeah, how do you get the position? As I said earlier, the total number of terms in a quadratic pattern is one more than in the linear,
So the smaller one.
right? So you take the one, you take the smaller one.
I want you to say that.
Thank you, sir.
Or the difference.
Okay, so please go back to the last item.
Right, I need to move on as well to the next question.
Let's say instead of starting 25, you start 26.
If you substitute 26 of the linear pattern, means you are saying there are 27 terms in the quadratic. Of which our question is saying we have got what? 26. So you can't substitute 26 here. You can't substitute any of 26. The moment you do that, you are saying there are 27 terms in the quadratic.
So you sum the smaller term.
Yes, among the two, you just substitute the smaller one. Yes. No, this is an indicator that there are 26. Okay? The way the question is phrased here, it indicates that for that specific pattern, there are 26 what? Terms. Yes, and the sheet 26.
Also, how many months of this comes to
Okay. Maybe around 20. Number of patterns with lots of marks in your September control.
20?
Yeah. The good thing is, up to what I've discussed so far, method 1 and 2, you should be able to answer number pattern, all the questions. I've covered everything. So after this lesson, you should be well prepared to answer the question in the test. Right? Okay, let me carry on. I only have 5 minutes. Then number 3 says determine the general term of the quadratic number pattern. I have done that. Now I want to give you a clue now as to why the second method was the best here, because if you find the general term in number 2, it means you have to repeat the same thing here. Do you understand what I'm saying? If you use method 1 to answer question 2, you have to repeat the determination of the general term in number 3.
So they don't want one above.
Well, in that case, no, not the one above. You need to rewrite it for part 3. So in my case, I'm not going to repeat it. All I'm going to do is duplicate my answer because I have got the capability to do that. Right? So I'm going to duplicate this. Right? Then I'll move it to the right position. You're laughing. In your case, you have no other option. You have to redo everything. So I duplicated it. I'll put it here. Okay.
It's a please take on next year, sir. I know you don't like on those. Take on.
Okay. So be aware that for question 3, this becomes question 3. Okay? That becomes question 3. And then I need to erase this. I've answered that already. Okay. So for me, I don't want to repeat it. In your case, if you're writing a test, then you have to. You want to get full marks. So this will be question 3. I've answered that. So let's move on to question 4. Are you following? Question 4, explain why this quadratic number pattern will never have a positive term. Now, this question now requires your knowledge of completing the square. Okay? Remember what I said earlier at the beginning. You are in grade 11 towards the end of grade 11. Therefore, all the concept to do with equations and all algebraic expressions and so on are now part of application to you. Okay? So this question now, it tests your knowledge of completing the square and its application. And one of the applications of the concept of completing the square is answering questions on number patterns. The good thing is we got the general term. So we use the general term minus 2n squared minus 2n squared plus 9n minus 1. What is the question asking? The question is saying, can this quadratic pattern have a term which is positive? That's what the question is asking. The answer is a yes or it's a no. Right? So you have to justify why you're saying it's a yes or it's a no. So we use the general term itself. Right? So first thing, we have to complete the square. So if I complete the square, first thing I must make the coefficient of n squared positive. Do you remember? Please, can you forget about the break and pay attention to what I'm saying now? Right? So you factor out minus 2, you get n squared, and that becomes minus, this becomes minus 18, or rather minus 4. Okay, I can call it 9 over what? 2. So this will be minus 9 over 2, n. Right? And this one here becomes a plus what? 11 over what? 11 over 2. If you factor out minus 2, you get this trinomial. Right? Your homework, but I don't have time now. I want you to go home and complete the square here. Our next lesson, when I see you probably on Friday, right? Then we can talk about that. Complete the square.
Oh yes, oh yes, oh yes.